Hey, Mr. B here. We're going to talk over scientific notation today. Within that, we'll be looking at two different goals or parts. So the first page, or the front of your page, part 1, is going to be to convert from scientific notation to decimal form and back from decimal form to scientific notation. Part 2, we're going to use properties of exponents that we've learned to make scientific notation computations. Specifically, we'll be multiplying with scientific notation, dividing with scientific notation, and taking scientific notation to powers. So let's start first of all with what scientific notation is. It's a way of expressing numbers that are too big or too small to be conveniently written in decimal form, or even numbers that we can write in decimal form, we can still write in scientific notation. Any number can be written in scientific notation. It's commonly used by scientists, mathematicians, and engineers, in part because it can simplify certain or arithmetic operations. So there are times where going to scientific notation is going to save you some time, energy. So here we go. Scientific notation looks like this. They're going to be in this form, something times 10. This is always a 10 to some power. Yeah, I said this is multiplication right here, and we're going to go back and use the old school multiplication sign. I know we've gotten away from that in Algebra 1, which is good. We don't want to confuse that with some variable, but here it's the old school multiplication symbol. And it's always the old school multiplication symbol with a 10. The C is going to be some number between equal to or bigger than 1 and less than 10. N is going to be the number representing the number of places the decimal point has been moved. So here are two examples of values that are written in scientific notation. First, let's talk about large numbers written in scientific notation. And when we say large numbers, those are numbers that are going to be greater than or equal to 1. Which doesn't mean it's necessarily that big of a number, but that's our focal point for large numbers. That's what I'm meaning when I say that. To do that, we're going to move the decimal point between the first and second non-zero number from the left. So let's do that right here. So in this first example, that would be right here. I just moved the decimal point to between the first and second number. Count the number of places you move the decimal point. Well, it used to be right here. That's what I just did there is made an invisible decimal point. This is where it used to be. So count the places. I like to make these egg crates. 1, 2, 3. See how that looks like an egg crate? 1, 2, 3, 4, 5, 6. I moved it 6 places. And it was to the left. If we're rewriting a large number to move the decimal point from where it initially was to where it's supposed to be in scientific notation, we would move to the left. Take a look at this huge number. We'd move it to the left. So we moved it 6 places here. Rewrite the number with the relocated decimal. So it's 1.5. Drop any zeros that were at the end. So these 5 are going away. Write times 10, and then the number of decimal places that we moved it is the power. Now I realize now that I think on this example right here, I don't believe you had these zeros. Oof. So that's why I'm crossing off these zeros, because if you look at yours, you have 6 zeros at the end of that thing. So now I guess we're calling this the new decimal point. So let's try that again. Move the decimal point between the first and second non-zero number. So here's the first non-zero number, here's the second non-zero number. So that's where the new decimal point goes. How many places do we move the decimal point to the left? Well, we moved it from here, 1, 2, 3. Hey, it's easy to count when we have the commas in there, huh? There's 3, 4, 5, 6. So you could actually skip making these egg crates. That's a messy egg crate. I don't know what kind of egg that is. So I'm sitting at 6, 7, 8, 9, 10, 11. I moved it 11 places. Rewrite the number with the relocated decimal, so 1.69. But I gotta keep on going, 6, 5, 2. And now once I hit all zeros, I don't need to write all of those zeros down. If there was some other non-zero number here, right there, I'd have to keep going. I would have to write all those. So that's my new decimal. And then I write times 10, and then the power is going to be the number of places that we moved it, which was 11. So there is my large number written in scientific notation. So really, like, this power right here is really powerful, but it tells us how many places that number got moved, how many decimal places it was moved. Let's look at small numbers. When I say small numbers, I mean numbers less than 1. We're going to move the decimal point between the first and second non-zero numbers. So in this case, that's right here. Count the number of places you moved it, move the decimal point to the right. Because if it's a small number, the decimal place starts right here originally when it's in decimal form, but when I move it to scientific notation, it got moved to the right. So that was 4 places. This is going to be a negative power. So rewrite the number with the relocated decimal point, 9.8. Drop any zeros and add times 10 to that negative power. So it's a negative 4. Let's try that again. Let's move the decimal point. It should go between the first 2 non-zero numbers, so right there. How many places do we move it? 1, 2, 3, 4, 5, 6, 7. 7 places. So it's going to be 6.942 times 10. And the power again is going to be a negative 7. When we have a negative exponent, that should indicate to us that it makes a really small number. So let's go backwards here. Let's get a number in scientific notation and then let's write it in decimal form the way we're used to seeing it. So we're going to take that decimal point that's sitting right, move, thank you, please. We're going to take this decimal point and move it 10 places. Now, because this is a positive exponent, it makes a number that's bigger than 1. I'm going to move it to the right to make, in fact, the power is 10. It's going to be a huge number. I wish I could make that on a paycheck. That'd be great. So I need to move it 10 to the right. So really, there's a couple ways of thinking about it. You could make egg crates and count out 10 egg crates. Then you'd have to put in 8 zeros. Or you could realize that, well, I need 10 places and then I need a decimal point. Now, don't count this one because that's already there. But I need to move this 10 more to the right. So there's 2, and then I'll need 8 zeros after that. So 3, here's my first decimal place that I'm going to move it. Second one, third, fourth, fifth, sixth, seventh, 8th, 9th, 10th. Then go back and add commas after every 3 decimal places from the right. There we are. And again, you could double check that. Count the decimal point used to be here, 2, 4, 6, 8, 10. Now there's an invisible decimal point there that we don't need to write in there. Let's try that one more time. So I'm going to move this decimal point right here 4 places to the right. 1, 2, 3, 4. So I'll have 2 zeros after the 2 ones. Go back in, put your comma. There we go. Now for numbers with a negative exponent, we're going to move the decimal point to the left because a negative exponent means a really small number. And so when we move the decimal point to the left, it makes a really small number. So there's 1. And now we do include the value to the left of the decimal point. So 1, 2, 3, 4, 5. This is my new decimal point. I actually need to make a decimal point here. Now where these egg crates are, we need to put real zeros. So I'm going to have 4 zeros. So my answer should look like this. Decimal point, 0, 0, 0, 0, 6, 7, 3. By the way, we should get in the habit of then putting a 0 out in front. I'm going to put it in a different color. But in science class, we need to have a 0 in front of the decimal point. Really, we should do that anyway. Why? In case we make a really tiny decimal point or blends in with a 0 or something like that, that way it should catch our eye that, oh, there's a 0, then a decimal point, then a 0. That's why. Just get in the habit of it. So 4 places, it's a negative exponent, so I have to move to the left. 1, 2, 3, 4, decimal point. So fill in the egg crates with eggs or zeros. I've got 0.0001223 and a 0 in front of that decimal point. In a second, so that's the end of part 1. Please do give some practice on 1 through 20. 1 through 10's writing numbers in scientific notation. And then numbers 11 through 20 are doing this, getting them from scientific notation into decimal form. Have fun with that. Seriously.